Unit 6, Chapter 9.1, Exponents, Order of Operations, and Inequality. Let's first talk about exponents. And exponents are just simply a shortcut for us to indicate repeated multiplication of the same number. And this shouldn't be unusual. Remember that what we do with just repeated addition of the same number is we have this thing called multiplication, where we take the number that's repeatedly being added and we multiply it by the number of times it's being added. And so that's why you have to memorize your multiplication tables, because it's not completely intuitive just looking at this as to what it means. Well, likewise, if we want to repeatedly multiply, and that's what factors mean, multiply, and we want to do a shorthand like we do with repeated addition, we use this thing called exponents. Okay, and so the four factors of 3 are listed here, and how we represent this as an exponent is the base, in this case the 3, is the number that's being repeatedly multiplied, and then the exponent, which is the 4, tells us how many times the number will multiply itself. Okay, a common mistake is students will see an exponent like this and they go, I know it involves multiplication. They see a 3 and a 4 and they want to multiply 3 times 4 and get 12, okay? And that is incorrect. 12 is not the answer to this. Remember, 3 to the 4th is 3 times 3 times 3 times 3, and the way you compute it is 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so here's an example. Just take a second and take a look at 5 raised to the 3rd power and compute that real quickly. Okay, and here it is. It's 5 multiplying itself 3 times. 5 times 5 is 25. Times 5 is equal to 125. Okay, and it also applies to fractions. Here we have the exponent and it's on a set of parentheses, so that means the entire fraction is going to be the base. And so take a look at this real quickly and compute an answer. Okay, well, this represents the fraction multiplying itself twice, and with fraction multiplication we have no cancellations. We multiply straight across. 3 times 3 is 9, 7 times 7 is 49. Okay, next is order of operations, and this is probably one of the most important sections that you need to master, because if you don't master this, you will often make mistakes when simplifying math expressions. Okay, so the first step is going to be if grouping symbols, in other words, there's some type of parenthesis present, then you simplify what's ever in the parentheses first using steps 2 through 4. And so by parentheses, of course, it could be the standard parenthesis, but you may also see squared off brackets. Those have no special meaning other than that's just another form of parenthesis. So within a parenthesis, or if there is no parentheses, what you do next is you're going to go ahead and apply all exponents. And we just talked about exponents. You do those first. And then you do multiplication or division in the order in which they occur from left to right. And I'll talk more about that in a minute. And then you do any additions or subtractions in the same order in which they occur from left to right. Now here's the problem. Most students remember from high school this little acronym PEMDAS, or please excuse my dear Aunt Sally. And so no problem, that's the parentheses, that's the exponent, and then they have multiplication and division. And if you view this as the strict ordering, you would come under the impression that the multiplication will always come before the division, and that is not true. It's multiplication or division, whichever occurs left to right. So you could be dividing before multiplying if the division comes first. And likewise, the A and the S is the addition subtraction. And again, if you view this as a strict ordering, you're going to make the false assumption that you always add before you subtract, but again, it's whichever occurs first from left to right. Okay, so this is left to right, left to right. You've got to understand that, otherwise you're going to make a lot of mistakes moving forward. Okay, let's look at some examples. Okay, this starts off relatively easy. So here I look at the expression. I have two things. I have a multiplication problem and a subtraction. Well, clearly multiplication or division comes before addition or subtraction, so this will be done first. And so I go ahead and do the multiplication. Now notice what I do on here is when I underline or I identify my first operation, that's the only thing that I do. And then I write the solution to that, and then I bring anything that hasn't been done down so that I'm always starting with a fresh mathematical expression. Well, obviously the only thing left to do is the subtraction, and we're finished. Another simple example here, we have a set of parentheses. So within the parentheses, the only thing I have to do is addition, so I'll go ahead and do that addition and add the 3 and the 8. And all I've done is replace the 3 plus 8 with its solution. I brought the 4 down, and now the 4 is multiplying. Again, if there's no sign in between the number and a parenthesis, that indicates multiplication. And so then 4 multiplying 11 is equal to 44. Okay, slightly more difficult, but not really. So when you scan this, you have a multiplication, subtraction, multiplication. So I want to do these multiplications first. Okay, since they're separated, I can go ahead and do them in one step. And so I'll do that, and notice that I did the 5 times 3, replaced it with the 15, the 2 times 4, replaced it with the 8, but I left the subtraction in place. And now the only thing left is a subtraction, which yields 7. Okay, so here it gets a little bit more interesting, and this is where you've got to be very neat when you do this. And so it's important that you only do one step at a time in order not to get lost. So if you scan this particular mathematical expression, you notice we have a set of parentheses. Within the parentheses we have subtraction and multiplication. Well, that means that we're going to do the multiplication first. That's the only thing you need to do. So I'll take my 3 times 2, which is 6, and I replace the multiplication with the answer, and then I rewrite the rest of the expression as it exists. This way I'm always starting with a new expression, and each time I do this, the expression gets a little shorter. Well, here I have 10 minus 6 in parentheses, so I must do that next. So 10 minus 6 is 4, so the only thing I did was replace the 10 minus 6 with its answer. I brought down everything else in the expression. Now I have multiplication, addition, and I have an exponent. Well, exponents would be next, so that would be the next item that I do. So 5 to the second power is 25, so I replace it, brought down the rest of the expression. Now I have multiplication, addition, subtraction. Well, multiplication is the highest operation, so I'll go ahead and multiply 3 times 4, replace it with 12, bring down the rest of the expression. And now I have addition, subtraction, so the rule says do whatever occurs first, left to right. So 12 plus 30 gives me 42, brought down the minus 25, and then finally my last step is to finish it off. Now notice how that's the way it should look when you do this. If you line up the equal signs, you're going to have this kind of V shape, okay? It's very important that you don't scatter partial answers all over your paper and hope that it magically comes together at the end. Underline what you're going to do that math problem, and replace it with the answer, and then rewrite the rest of the expression as it is, and just continue to eat away at it until you finish the problem. Here's one more. Feel free to pause the video and try it, but we'll go ahead and complete it if you don't want to. Now notice we have a set of brackets and a different set of parentheses. Okay, these both represent just parentheses. So the brackets are the outer parenthesis, which means we're going to go into that first, and within the brackets there's another set of parentheses, which means we go to this first. And so this 4 minus 1 will be the first operation that we do. And so 4 minus 1 is 3, so all I've done is replace it, brought everything else down. I still have a bracket, even though there's parentheses here. It's only representing that there's multiplication. There's nothing to do in the parenthesis. And so within this bracket, 2 times 3 is the highest priority operation. 2 times 3 is 6. I bring down the answer, rewrite the rest of the expression. I still have work to do in the bracket. So 9 plus 6 is next, which is 15. So I'll replace it with its answer. I keep the bracket because the 3 is multiplying whatever was in the bracket. And finally I do the multiplication. 3 times 15 is 45. Again, notice this V shape. It's very neat and organized. It would be very easy for your instructor to follow what you're doing if you do it like this. Okay, and finally, we're just going to introduce the idea of an inequality. Okay, here are the symbols. Okay, so the equal sign with a line through it does not equal. So you might see it written like this, and the way you would say it is 2 does not equal 5, which is true. Okay, this symbol from left to right, it points to the lesser and opens to the greater, so this is a less than symbol. So here's an example of it in use. 3 is less than 4. If it has a line underneath it, then that means to include the equal. So this is less than or equal to. So 5 is less than or equal to 7. Okay, here again, reading from left to right, it opens to the greater. So this is the greater than symbol. So its use would be something like 7 is greater than 3. And finally, likewise, here's the equal to part, so this would be greater than or equal to. 8 is greater than or equal to 8. That's true because they are equal, so it can be either or, either greater than or equal to. And so that's example of the use. That concludes this section.